Hello everybody. So in this video, I'm going to show you how to find residuals and how to make a residual plot. We'll begin by opening up the Chapter 5 Excel example spreadsheet we were using in the last video. And we're going to click on the bottom where it says Example 4.3 Residuals. Okay, so let's begin. We're going to start by going to Data, then over to Data Analysis, and then click on the button that says regression and click OK. Now, the way that we find the residuals and graph the residuals will also give us the slope and y-intercept for the regression equation. However, it's much easier to do it the way that I showed you in the last video because it'll graph the regression line with the scatter plot at the same time. So let's begin. Notice in the first box, the cursor is blinking and it says input Y range. So what I'm going to do is highlight all the Y values without the labels. So in column C, starting at C2, all the way to the bottom at C52. And then I'm going to click in the box that says input X range. So now I'm going to highlight all the X values starting in the B2 cell all the way down to the B52 cell. So those are now both inputted. Now this is a little counterintuitive because they ask for the Y first and then they ask for the X afterwards. You're going to see some boxes here that are asking if they want to be checked off. The only time that you're going to check off the box that says labels is if you highlight the labels with the data itself. But since I didn't do that in the first step, I don't have to worry about checking off this box. And then we're going to ignore the other two boxes for confidence level and constant is 0. So ignore those two as well. Okay, next, output range. I'm going to click on that because I don't want it to put all this into a new spreadsheet. So in the output range, we need to select a blank cell, and I'm going to go all the way to the top for it to print out the output for this. So I just selected the E1 cell. And then next, you're going to see a box that says residuals. So for that, I'm going to click on the first box that says residuals. So that way it gives me the residuals itself. And then afterwards, I'm going to click on the box that says Residuals Plot. So that way it graphs the residuals as well. So once I have all of that, I'm going to click OK. And then it's going to spit out a bunch of stuff. So I'm going to go over this briefly. So first things first, here we have the residuals plot. Now remember, the residuals plot is telling us the error produced from the regression line equation. And it's a little counterintuitive because the way that residuals are defined is it's observed, which is actual, minus the approximation from the regression line. So because of the way it's defined, positive residuals, which are dots that are above the x-axis, represent under approximations, versus dots on the residual graph below the x-axis represent over approximations. So this is just a dot, this is just a scatter plot for all the errors themselves. So there's a bunch of stuff that's printed out here that is also pretty useful. Whenever we do this, it's giving us R and R squared, which are meaningful and useful for some of the things we're going to be doing. However, you can get R squared by finding the regression line the way I showed you in the last video. One other thing that you want to notice here is the coefficients that are listed here. The y-intercept under coefficients is given to us, and below that is the slope. So if you wanted to just do the regression equation without having to produce a scatter plot, you would have to run through these menus and it would spit this out right here. Okay, but that's not what I really wanted to show you. I wanted to show you how to get the residuals plot, and then it actually gives us the residual values right here below. So it tells us observation number, the predicted Y value for each X, and then the residual. So what it's doing for, let's say, observation 1 corresponds to Alabama. So what it does is it does 538 minus the predicted, which is 577.607649, and it gives us the error there, which is negative 39.607649. Okay, and then it does this for the remaining points as well. So it's giving us the list of all the error values in addition to the graph. Now, one thing I want to show you here is that when you add up the residuals, it should total 0. Now, of course, because Excel is probably rounding some things, it's going to be true up to round off error. So how can I check that? Well, in the F76 cell, I'm typing in sum of residuals. And in the empty cell next to that, I'm going to type in equals, in all capital letters, sum, open parentheses, and then I'm going to highlight all the residuals, starting from the first up until the last. Close the parentheses, hit enter. And when I do that, it gives me 6.25278 E negative 13. Now you might say, what is that? Well, this is referring to scientific notation. This is basically about 6.3 times 10 to the negative 13. So that means the decimal place is moved over 13 spaces to the left. So in other words, there's going to be 12 zeros in front of the decimal and then 6.25278. Essentially, this is so tiny that it's about 0 up to some round off error. Another thing that I'd like to show you, and let me just highlight this, is the correlation between the X values and the residuals themselves. So for the correlation R, and this correlation here, excuse me, I'm going to use a little R, is not the same correlation from the data. I'm just talking specifically about the correlation for the graph of the residuals plot. So R here, and let's say the I22 cell, and then in the J22 cell, I'm going to type in equals Corel, parentheses, and then I'm going to put in the X first as the explanatory. So that's going to start from B2 all the way down to B52. Comma, and then I'm going to put in the response as the actual residual values. So that's going to start here in the G25 cell and go all the way down to the G75 cell. Then close the parentheses and hit enter. And we get that the residuals, or sorry, the correlation for the residuals is about 1.23852 E negative 16. So that means E negative 16 means times 10 to the negative 16. So in other words, there's 15 zeros in front of the 1, and then 1.23852. So that's so small, it's practically 0. And this is something else we're going to talk about in class. Whenever you're looking at the correlation for the residuals graph, it's also going to have a correlation of 0. And that makes sense because when you take a look at the graph, the dots are all over the place. Okay, so if you have any questions, please let me know. What I'd like for you guys to do is repeat this process. Run through the data analysis to go ahead and find the residuals, the residual graph, the sum of the residuals, and then the correlation for the residuals graph for Applier Knowledge 5.8. And this is for a smaller data set, which is looking at the sea surface temperature versus the coral growth rate. And that's on page 142 in the textbook. Okay, guys, so if you have any questions, please let me know, and thank you for watching.